To finish off section 2.2, I'm going to go through this example here where rather than starting with the angle, we're going to start with one of the trig functions and find the angle. Okay. I have a trig function here, cosecant of theta is negative square root of 2. And so what I want to do now is find all thetas, all possible angles that have this value for the cosecant. The first thing I recognize is that a square root of 2 is generally going to refer to a 45-degree angle. And remember, my two special triangles, just as a quick reference, you're going to want to be familiar with these. We've talked about these triangles already several times, but if you have a 45, 90 triangle, then the three sides that we used to build that were sides of length 1, 1, and square root of 2. And for a 30, 60, 90 triangle, we had side lengths of 1, 2, and square root of 3, okay? And so anytime you see a square root of 2, you're probably going to deal with a 45-degree angle. If you're dealing with a square root of 3, you're probably working with either a 30 or 60-degree angle, depending upon if it's sine or cosine or tangent or whatever. So this one, we're dealing with a 45-degree angle. So I'm going to think about my acute angles first, and then think of them in terms of the other three quadrants. So the first thing I want to do is try to find any angle, acute angle, in the first quadrant, where the cosecant is equal to the square root of 2. Well, and I'm going to ignore the negative for just a minute. Well, the cosecant being a square root of 2, I don't really know cosecant very well, but I do know SOHCAHTOA. Okay, I know that the cosecant is the reciprocal of the sine, and the sine is opposite over hypotenuse. So, referencing that back, the cosecant must be hypotenuse over opposite. It's the reciprocal. Okay, so I could, let's see. So a cosecant being square root of 2 means that the sine is 1 over the square root of 2, which is what you would get on a 45-degree angle, right? So sine is opposite over hypotenuse, that's 1 over root 2. And so that's going to be a 45-degree angle, that's the reference angle. So I know the sine of 45 degrees is 1 over root 2. So whatever angle I'm finding, it's going to reference back to a 45. So it's going to be some version of 45 degrees in the other quadrants. The other thing to keep in mind is that the cosecant is negative in the same quadrants that the sine is negative because they're reciprocals. And the sine is negative, if you remember our diagram, ASTC, sine is positive in the second quadrant and in the first, but it's negative in the third and fourth, okay? So sine is negative in the third and fourth, which means theta is in quadrants 3 and 4. In fact, there's going to be two such angles, theta. So we'll call them theta 1, theta 2 if you want to. Okay, so we'll call this one theta 1 and this one theta 2. So there's two different angles. One of them's in quadrant 3, one of them's in quadrant 4 because the sine is negative in both of them, and therefore the cosecant will be negative in both quadrants. Okay. Okay, so there's a lot of just thinking and processing going through these problems. There's not like simple calculations, right? These are like, they're complicated. You're processing the negative and the positive in the quadrant and which special triangle to work with. and the reciprocals of functions and things like that. So there's just so many different things to pick apart in these problems. There's not just, it's not like an algebra problem where you're solving an equation, it's like subtract this from both sides and all the way to the end. This is more of just like thought process, like you're trying to identify different pieces that you need, and then tinker and reason until you've figured those pieces out, and then put them all together at the end. So it's like a giant puzzle to put together. So that's what I'm trying to work through. So I know that my angles in the third and fourth quadrants, and so all I need is the corresponding angles to 45 degrees in those two quadrants. Okay, so if you think about that, if I were to draw an angle in the third quadrant that has 45 as a reference angle, well, that's going to be 180 plus 45. So theta 1 is 180 plus 45. Well, that should be what? 225. Okay, so 225 is my first answer. Then in the fourth quadrant, I'm looking for an angle whose reference angle down from the x-axis is 45. And so to figure that out, I could take 360 minus 45. Okay, so theta 2 is going to be 360 minus the 45 degree angle. And of course, I like to draw these out. It just helps me wrap my mind around what to subtract from what. So 360 minus 45 is, what's that, 215, right? So that would be, or no, I'm sorry, 315. That's a 315 degree angle. And so 225 and 315 should be the two angles that create a cosecant of negative root 2. So these are my two answers, right here. And it's because if you were to calculate, or if you were to punch into a calculator, for instance, it's hard to do a cosecant, but on the calculator, but essentially the cosecant of 225 degrees is negative root 2, and the cosecant for 315 degrees is also negative root 2, okay? So this is why these two answers are correct. So we're looking for the two angles whose cosecant value is negative root 2, okay?